Good morning, everybody. Well, I tried to teach this morning, and all I got was lag. So I wanted to spend a little time talking again about what we can expect from the game that we were talking about, the workplaces game. And you did have a chance to watch Ms. Barrett and Mr. Long play it. This is a game that's on page 4 of your book. And obviously, as you can see, you can play it a number of different times against different people, and you can vary it up to try and play it different ways. So I'd encourage you to do that with another person at home. Doesn't have to be an adult. It can be brother, sister, friend, whoever is in your little bubble there that you have that you can talk to. This is the next part that I'd like you to look at. It is in your student book on page 2. It says choose 15 problems below to solve. This will help you look for friendly numbers and friendly types of problems that you can solve, but it'll also challenge you. Like, for example, when you look down here at 12 times 9, we've talked about tens are friendly numbers, and all it's asking you is basically a 10 times 12, but take away one of the 12s because you only have 9 times 12. So it's just another way to look at the problem. But solve 15 of those on your own, please. And if you need to copy it down, you'll want to freeze this screen so that you can write it in a notebook if you don't have your math books yet. So freeze this screen if you need to. You can write it on a piece of paper with a pencil. And I think you have, it looks like 30 problems to choose from, and they're asking you to do 15. They're also going to ask you at the bottom, how did you solve these problems, or how did you decide which problems you wanted to solve? And obviously you can use the friendly numbers answer if you want. It's totally up to you. All right. The products game problems. This is another page within your math book. Not too hard. I think we all can probably be able to do something like this. Chloe and Ava were playing the product game. Their factor markers were on 4 and 5. Ava decided to move the marker from 5 to 7. So now you have 4 and 7. So it's a little bit about the game, what they did, and you solving a problem, being able to, or writing the problem that allows someone to guess or be able to tell which problems they're on. Chris and Katie were playing the product game. Their factor markers were on 9 and 2. Chris decided to move from 2 to 6. Write the numerical expression to represent the move. Eric and William were playing the product game. William put an X on 42. One factor in the marker was 6. What's the other one? Number 3. Cindy placed an X on the product 36. What are all possible locations of the 2 factor markers? Eli placed a 0 on the product 24. What are all the possible locations of the 2 factor markers? In other words, what factors multiply together to give you 24? Hannah and Sean were playing the product game, and Hannah needed to land on the product 18 to win the game. The markers were on 4 and 6. What factor marker should Hannah move, and where should she place it? Solve the following problems. If you need to hit pause on this, go right ahead. It might help you with being able to work on this if you don't have the page. And finally, more product game problems. We're going to leave this one alone, okay? I'm sure you're all going to be cheering and happy. Facts and boxes. This is something we have not talked about yet that I've been wanting to talk about, but it's virtually impossible to do with a laggy setup. Write an expression with parentheses to show how Kaylee would solve 9 by 5 or 9 times 5. Well, what is 9 by 5? 9 times 5. So when you go across to 9 and you move your other array side to 5, so it's like having 9 in a row, but then it's 5 high. Marshall says he'd rather use 10 times 5 to find 9 times 5. Because 10 times 5 is 50, that's friendly. 9 times 5, it'd be taking away a 5. So how would you show that? 10 times 5 in parentheses. Let me see if I can write that here. I'm going to try it. 10 times, sorry, this is painful to watch, I'm sure, for those of you who are like, hurry up and write. In parentheses. Oh, there went my 1. I'm going to change color. Minus, and we're just taking away a grouping of 5. All right, match each expression with the correct box. 4 layers of 3 by 5. 4 layers of 3 by 2. 4 layers of 3 by 4. Well, if I look at this is a cube right here. It's 3-dimensional, so there's the top right there. That whole thing is a cube. I can't see the side over here. I can't see underneath. I can't see these other sides. That's one whole cube. This is one whole array of 3 by 4. And there's another 3 by 4 crammed right to it. So, let me see if I can erase that so you can now see it back the way it was. So if we were to go vertically, you'd have 3 by 4 there. But when you go just on a base layer, you have 3, but it's just too wide. 3 by 2 on the base layer. And you add another 3 by 2. So I'll write that. 3 by 2 on the base. And then you add a second layer, and a third layer, and a fourth layer. So it's 4 layers of 3 by 2. Boom. Can you figure out the other ones? You can pause it and go ahead and do that if you'd like. All right, fill in the dimensions. Well, we have a base layer of 1, 2. It's 2 by 1, 2, 3, 4, 5, 6. 2 by 6. And then how tall is it? It's only 2 tall. Two by 6 by 2. All right? Very good. And then you can solve these problems at the bottom. That's all I have for you today. Thank you for giving me a chance to help you learn a little bit more about what we're doing with math.